so we're talking about volume this time. So volume would be measured by cubic meters. So when we talked about area, we said that when we calculate the area of a shape, we count the number of squares or unit squares inside that shape. So if we follow up on that thinking, then we could say that volume would actually be counting this time the unit cubes that make up that shape. Okay, so just like this one here, how many cubic centimeters are in each solid shape? The same thing when we did area, it would be efficiently counting the number of unit squares, this time efficiently counting the number of unit cubes. That one there, if you count that, that's 3 by 2 by 1, 2, 3, 4, 5, right? So 3 times 2 is what? 6 times 5 is 30, and therefore you have there 30 cubic centimeters. Okay, so the same thing with odd looking shapes like these ones here. You count the number of cubes. So the first, the bottom row there would have 1, 2, 3, 4, 4 by 3. So you have 12 here, and then you've got what, 6 here, and then another 3 there, and therefore you've got 21 cubic centimeters. Okay, now what if they don't look like they're divided into unit cubes? Then what we will need to do would be to simply have a look at what would be the dimensions of that prism. Okay, so prisms would be named after their cross section, or what you call your slices. Okay, so when you have a rectangular prism, you can actually slice them this way. You can also slice them horizontally, or even, where's the other way, vertically, this way. Okay, and you'd end up with slices which would have the same shape, the same area of that shape. Okay, so in this case we could say that it's the area multiplied by the depth, or if we talk about the area of the cross section or of the base, the bottom, right? So that's area of the bottom multiplied by the height. Okay, so what's the area of the bottom? That's 4 times 7, that's 28, and multiply that by 2, and therefore you get 56. Okay, does that make sense? So that's why they've come up with the volume formula, which is A times H, right? So the base of a prism is the uniform cross-section of the prism. So when you say uniform cross-section, your slices are uniform to each other. They have exactly the same shape, exactly the same area. Okay, so the base of the prism could be of any shape. It can be a rectangle, it can be square, it can be triangle, it can be a trapezium, it can be a pentagon. The height of the prism is always perpendicular to the right angles to its base. Okay, now sometimes when they draw the 3D shape, it doesn't have to always be on the bottom. So those are the things that you probably want to look out for, right? How the shape would be turned, okay, turned to the right or left or whatever. Okay, so in this case, our cross section would be the one on the bottom. All right, so there would be 6 square meters, and you multiply that by the height, which is 2 centimeters, and therefore AH, if you apply that, you get 6 times 2, you get 12 cubic centimeters. Okay, so the same thing when you have you don't call that a circular prism, but there's a special name for it. Anyone who knows what's the special name for that? Yes, cylinder. Okay, so when we have a cylinder, the area is already given there, which is 120. And therefore, if you have 120 multiplied by the height, multiplied by 11, and therefore you get 1,320. Okay, so the same thing with example 18. So this time your cross section would be a composite shape, and therefore you'd probably need to be doing a bit of some problem solving here, a bit of a strategy. right? You might want to cut that over here and say that there's 2 rectangles there for you to figure out the area of the cross section, okay? And therefore that's 3 times 2, that's 6. This one is 2 times 1, that's 2. 6 and 2 gives you 8, right? Therefore the area of the cross section is 8, but what's the height? The height would be 3, and therefore 8 times 3 would give you 24. Okay, see you all at school. Bye.